So question 1, we have to find a missing angle. We have to find angle BDC. Is written there, angle BDC. That just simply means the angle that's produced if you go from point B to point D to point C. Okay, so the angle that we're talking about is that angle there. Okay, well the first thing I would notice is we have an equilateral triangle, and we can see that because we've got this line here, and this line here, which means that the sides, this side here, and this side here are all the same length, and all the interior angles of this triangle are the same. And we know that angles in an equilateral triangle are 60 degrees. So I'm just going to write those in now, and that one there. So 60 degrees. Okay. That will get me 1 mark for just identifying the equilateral triangle has an interior angle of 60 degrees. 3 marks for this question. Second mark for quite simply identifying that angles on a straight line add up to 180 degrees. So this angle here is quite simply 180 take away this 60 degrees. So that means that this angle here is 120 degrees. We're nearly there. That's got me my second mark. My final mark then is for finding the angle that I've been asked to find, BDC, and I can see that it's the final angle in a triangle. Angles in a triangle add up to 180, so this one plus this one plus this one add up to 180. So BDC is 180 take away this one plus this one, this one plus this one, which is 144, which means the angle I'm looking for is 36 degrees. So let me just recap on the 3 marks. 1 mark for the interior angle of an equilateral triangle being 60 degrees. Then using the angles on a straight line rule to work out this one being 120 degrees. Then finally, to get our answer for the 3rd mark, angles in a triangle add up to 180. So 180 take away this one plus this one gives me my 36 degrees. Okay, so on this question, we've got a simple function machine where you have something, we call it an input, some operations happen. So in the example, we've got something gets put in, call it n, add 4 to it, then times 3, and that can be written as that's something plus 4 all times 3, so it's 3 brackets n plus 4. So what we've got to do is we've got to repeat the same process with the 2 examples A and B, and they're given 2 marks for each of these, which is quite generous. So let's have a look. We've got something, let's call it n, and then we times it by 2. How do we write that? Well, we got something, we times it by 2, we call it 2n, and then we take 5. Okay, so what we should actually be looking at doing then in our output is putting that in 2n minus 5, and that will get you 2 marks, which, as I said, is pretty generous. All right, let's have a look. Second one then. Looks like it's a bit harder, but more like the example. We've got something n, and we add 1 to it. Okay, so what's that look like so far? N plus 1. Okay, and then we divide by 4. Do you see that? We've got n, we add 1, n plus 1, and then we divide what we've got so far divided by 4. Okay, so let's move away from the old divide by signs, a bit primary school, and what we do is we go divide by 4. We write it like that. So your answer in your output box, if we rewrite that, is n plus 1 divided by 4. Okay, and 2 generous marks for that, guys. Okay, so 4 marks in your GCSE. You should be laughing if you see a question like that. Okay, question 3 is a fraction question, and it looks a little bit tricky when you first read it. What do we get? It says, on one day, 7/8 of the workers at an office arrive on time. 1/10 arrive late. The rest of the workers are absent. What have we got to work out? Calculate the fraction of workers who are absent. Give your answer as a fraction in its simplest form. So there are 3 marks available for this. What I'd do is I'd work out, if I've got to work out how many are absent, well, let's work out a fraction together of those who arrive on time and those who arrive late. So we're going to add those fractions together. So we get 7/8 plus 1/10. Okay. Now, when we're adding fractions, we know that the denominators, the bottom numbers, have to be the same. Okay, so we're going to rewrite the sum as a fraction plus another fraction, but these bottom numbers need to be the same. The way we do that is we look at these 2 bottom numbers and we say, what's the smallest number that's in both of those times tables? Okay, so you can spend a bit of time thinking about that, but most of us will eventually get to the point that we realise that 40 is in both of those. Okay, so this sum here has to be equivalent to this sum here. So what I do to 8 to get to 40, I must do to 10. Well, let me just scrap that. What I do to 8 to get to 40, I must do to 7 to get to 40. So I times 8 by 5, I must times 7 by 5, which gives me 35. Okay, so 7/8 is equivalent to 35 over 40. I times that by 5, I times that by 5. Okay, what do I times 10 by to get to 40? I times it by 4. What must I do to the top? Also times it by 4. So we get 4 over 40. When we add fractions, the bottom number stays the same. 35 plus 4 is 39. Okay, so the fraction of workers that arrive on time and late added together is 39 over 40. So what have we got of 1 whole left? Okay, well that is 1 take away 39 over 40. Okay, and so that is 1/40 that's left. Okay, so we're looking at 3 marks for that question. Essentially, you're going to get 1 mark for this part, 1 mark for this part here, and a mark for the correct answer written in your box. So I'll just write that answer in the box there to get my 3 marks. Okay, so we've got a probability question. Janice has a dice with sides numbered from 1 to 6. Her dice is biased. She rolls it 200 times and gets the following results. First thing, just as we're reading that, what does bias means? It means that there's not an equal chance that it will land on every side. It means it's kind of biased to a particular number. It's going to land more times on one or more specific numbers. Okay, so people use biased dice to cheat when they're gambling. But let's look at the question. She rolls it 200 times and gets the following results. She gets a 131 times, 229 times, etc. Estimate the probability of getting a 6 when the dice is rolled once. So 6 is 20 times out of 200. So what I do is I write 20 times out of 200, and that could be cancelled down to 1/10. And a quick way of cancelling for anybody, if there are zeros on top and the bottom, like this and like this, what you can do is you can knock one off the top and one at the bottom, so you get 2 over 20, which can be simplified to 1/10. Okay, so that's got me 1 mark there for that question. Now, what does it say? Describe what Janice could do to get a better estimate of the probability of rolling a 6 when the dice is rolled once. Okay, so we've generated our probability from rolling it 200 times. The fact is, the more times we roll it and record our results, the better estimate of the probability we get. So quite simply, if you see a question like that, just say roll the dice more and record the results. You might have said something like repeat the experiment more times. That's fine. It's 1 mark, as long as we're saying the more times we do it, the better our estimate of the probability. Okay. How many times should Janice expect to get a 4 if she rolls her dice 300 times? Okay, so what we do is we work out the probability of getting a 4. Okay, so let's have a look back at our table. Probability of getting a 4 is 24 out of 200 times. 24 out of 200 times. Okay, 24 out of 200. And you just take that probability and times it by, let me just type that up, times it by 300. Now if it's calculated paper, that's just dead easy, but this is a non-calculated paper. So what we do is, quite simply, we can turn those into fractions. You can cancel down diagonally if you wanted to. And then we could rewrite that as, well, 24 divided by 2. 24 divided by 2 is 12 times 3, which is 36. Okay, so 2 marks available. 1 is for the calculation, 1 is for the answer. It's the probability times the number of times you roll the dice. Like I say, calculator, it's dead easy. Non-calculator, it is a bit harder, guys. Factorising is the reverse of expanding brackets. What we do is we look at the 2 terms here and we say what's the biggest that they have in common. And I start with the numbers 3 and 6. What's the biggest number that goes into 3 and 6? And you're probably going to get to 3. Do they have any letters in common? Yeah, you can see a B goes into both of them. So I take that outside. They don't have an A in common. So basically the 3B lives outside the brackets. Okay, so we started with the numbers. Biggest number that goes into 3 and 6 was 3. Biggest amount of letters they had in common was a B. That lives outside the brackets. Okay, so we've got to decide what goes inside the brackets. So what do I multiply 3B by to get to 3AB? And the answer is A. What do I multiply 3B by to get to 6B squared? Start with the numbers, multiply 3 to get to 6, it's going to be a positive 2. And B to get to B squared is B. So my answer is, for that one, 3B brackets A plus 2B. Okay, that's good. Okay, so factorising is the reverse of expanding brackets. And now the next question is expanding brackets. So multiply what's on the outside by both the things on the inside. So 4 times 7y is 28y. And 4 times 2 is 8. So we put plus 8. Okay, so there's an extra mark in our GCSE if we had that one there. Okay. Next one, we're going to expand some brackets and then simplify. So there's just an extra step which we're going to do at the end, which is reflected by the extra mark on this question. So let's do x times x, which is x squared, then we do x times minus 5, which is minus 5x. Then we do the plus 4x, and then 4 times minus 1 is minus 4. Sorry, missed a bit of my x there. Okay, so x times x, x squared, x times minus 5, minus 5x, 4 times x, 4x, and 4 times minus 1, minus 4. Let's just simplify that. X squared minus 5x plus 4x minus x. Some of you might have put minus 1x, that's okay, but let's get out of the habit of writing a 1. So it's minus x, and then we've got the number minus 4. So 2 marks available for that. Okay, 1 mark for the first thing, and then the second mark for simplifying accurately. Okay. Okay, a lot of people find these questions a bit tricky. We're given some information. It says use the information that 11 times 9 equals 209 to then find the value of this. So we're not going to use a calculator, we're going to use the information that we're given. 11 times 19 equals 209. So what's 0.11 times 19? Okay, well the difference between this question and this is the first thing is 100 times smaller than that, which means our answer will be 100 times smaller than this. Okay, so quite simply our answer is 2.09. Okay, so if you want a quick way of getting 100 times smaller, remember decimal points at the end. Okay, decimal points at the end. 1, 2 decimal point would go there if it was 100 times smaller. Okay, so 2.09. Okay, what have we got next on the next question? 20,900 divided by 1.9. Okay, so we go back to our information, and if we know that 11 times 19 is 209, you should know that 209 divided by 19 gives you 11. You could kind of do the reverse. I'm just going to write that down for you just so you can see that. So 209 divided by 19 equals 11. Okay, so what's the difference between the sum we're given and the original information we've got? Well, two things really. The number that we're dividing into is 100 times bigger. Okay, so if that was the only difference, our answer would be 100 times bigger as well. But the number that we're seeing we're dividing into, the number we're dividing by, okay, is also 10 times smaller. So the number we're dividing into is 100 times smaller. The number we're dividing by is 10 times smaller. So a combination of those two differences means our answer would be 1,000 times bigger. Okay, so 20,900 divided by 1.9 equals 1 and then 1,000 times bigger, 1, 2, 3 zeros. Would give you the answer to that. So just to clarify, the number we're dividing into is 100 times bigger. That means that this answer would be 100 times bigger as well. So that would add me 2 zeros. And the third zero that I get in my answer is because the number I'm dividing by is 10 times smaller. If you divide a smaller thing into something, it's going to fit in more times. Well, in this case, 10 more times. Okay, so a combination of that means my answer is 1,000 times bigger than the original information that was given. All right. Okay, so highest common factor, jumping out here. We use the information that 11 times 19 is 209 to find the highest common factor of 66 and 418. Well, if 209 is 11 times 19, then 418 is 2 lots of 11 times 19. Okay, so what we have to do is we have to work out what 66 is as a product of prime factors, if you remember products of prime factors. So I'm going to write 66, two numbers that multiply together to give 66. Come on then, guys. 2 and 33. Just circle that. Two numbers that multiply together to give 33 is 3 and 11. I circle all of those because they are the primes. So 66 is 2 times 3 times 11. So what do they have in common? What's the highest common factor? So you look at what they have in common. They've got a 2 in common. Okay, so highest common factor is 2, and they've also got an 11 in common. 2 times 11, which is 22. Okay, so the highest common factor of 66 and 418 is 22. Nice one. Okay, you open up your GCSE paper and you see there's a scatter graph question. The first thing you really need to be doing is draw a line of best fit. You guys use your ruler for this, and essentially what you do is you draw a line going straight through the centre of the mass of the x's that have been marked on the scatter graph on the graph paper. Okay, everyone will have a slightly different one. There's no perfect way of doing it unless the x's all connect up to give a straight line. Use your ruler. I haven't used a ruler. Forgive me for that. But that usually will get you 1 mark, and actually on this marking scheme, so we can see in a little bit, that will give me a mark. But just get in the habit, see a scatter graph, get your line of best fit drawn in. So what does it say? Scatter graph shows the number of hours of sunshine and the maximum temperature for 8 cities on the same day. Okay, it says describe the relationship between the maximum temperature and the number of hours of sunshine. So number of hours of sunshine, maximum temperature, you can see with the line of best fit that they are increasing. So maximum temperature increases as the hours of sunshine increase. Okay, so we describe that as a positive correlation. But if you decide to write a sentence saying as the hours of sunshine increase, so does the maximum temperature, you'll probably get 1 mark. But let's just get in the habit of recognise if the line is diagonally going upwards from left to right, it's a positive correlation. If it's going downwards from left to right, it's a negative correlation. And if there wasn't a clear way of drawing a line of best fit, we say no correlation. Alright, so another city had 3.5 hours of sunshine on the same day. Use the graph to estimate the maximum temperature in the city. So another city had 3.5 hours of sunshine on the same day. Okay, let's use the graph to help us. And this is where the line of best fit is going to help us. So 3.5 hours of sunshine this one had. So 3.5 is that. Okay, what we should do is we should draw a line going up with our ruler, ideally, and then what you do is you then come across here. Okay, so mine's a bit messy because I've not used a ruler. You guys will use a ruler. Okay, but you can see that you can do an estimate of, what is it? It's about 11.5 degrees. Okay, on that one there. So that's pretty good. So 2 marks for that, guys. 1 mark is for a line of best fit and that vertical line using a ruler and that horizontal line to show where you're reading off. If you don't have that, you're basically throwing away a mark in your GCSE. Okay, so you've got an nth term sequence question. What you do is you get a sequence, you've got to work out what's going on. Okay, so to get from 1 to 4, 5 to 9, 9 to 13, and to 17, we can see that we're adding 4 each time. So find an expression in terms of n for the nth term of the sequence. The term-to-term rule is we add 4. What we've got to do is we've got to find the formula, it's called the nth term, formula that will tell me for any position, it will tell me what the number in sequence is. So if that's position 1, that's 2, that's 3, that's 4, that's 5, it should be able to tell me for any position what the number is in the sequence. And quite simply, the method that we use to do this is we take the term-to-term rule 4, add 4, and we times that by n. n is the position, so we're going to replace n with the position number that we might be looking for. So let's test it to see if it works on the first position. So let's make n 1. 4 times 1 is 4. Oh no, the first number in the sequence is 1. How do we go from 4 times 1, 4, to 1? And we just do a simple adjust by taking away 3. Let's just test it works. Let's test it on the third one. Okay, so we make n the position 3. 4 times 3 is 12. 12 take away 3 is 9. And look, the third term in the sequence is 9. Okay, so that will get me 2 marks in that GCSE question. So now do the same again for the next one. Work out the term-to-term rule, what's going on each time. And this time we can see that it's taking away 2. It's getting smaller, isn't it? Minus 2. Okay, we put that in front of n. Minus 2 times the position that we're looking for. Let's just test to see if that works. Okay, the first term is 1. So let's do minus 2 times 1 is minus 2. But oh no, the first term is actually 18. Minus 2 times 1 is minus 2. How do I go from minus 2 to 18? U plus 20. Okay, it's quite a tricky one, that. Let's just test it. Let's test it on the second one, just to show you that it works. Okay, we make n 2. Okay, minus 2 times 2 is minus 4. Minus 4 plus 20 is 16. So we know it works there. Okay, so 2 marks again for that one there. Okay, quite a tricky question. Okay, question 9 involves a triangle within a circle. What we're going to have to get our heads around for our GCSE is some things called circle theorems, which gives us some rules to calculate angles within a circle. Okay, there are a few rules. One of the easier ones, is where we've got the diameter A to B. We're told AB is the diameter, and they use AB as one of the sides of a triangle within a circle. The simple rule, and you're going to have to learn most of them, the simple rule is when you've got a triangle with one of the sides being the diameter, the angle at the circumference is a right angle. That's supposed to be like a square. That means it's 90 degrees, which means angle ABC, that angle there, okay, ABC is angles in a triangle, which is 180, angles in a triangle, 180, take away the other two angles, the 90 plus 28, okay, so minus 118, which gives you 62 degrees. Okay, like most circle theorem questions, they then give you a few marks if you can explain what you do. So there are 2 marks available for the last part, okay, where you just give reasons for your answers. Okay, and the first one was we worked out, we saw that angles in a semicircle equals 90 degrees. Okay, that gives me one of the marks, and the other mark is, in fact, let me call that 2 for the second mark. Angles in a triangle equals 180 degrees. So all I'm doing is just saying the rules that I use to get the answer up above. Okay, nice one. Okay, question 10. Shop starts selling a new camera. The shop is open 6 days a week. The table gives information about daily sales of the camera over the first 2 weeks. Number of sales, 3. Number of days that happened, 4. Number of sales, 4. Number of days that happened was 3. Number of sales, 5. That happened over 2 days. 6 sales only happened on 1 day, and 7 sales happened on 2 days. Okay, so what we've got to do is answer these questions on averages. For this data, write down the mode. Okay, well, the modal amount, or the mode, is the most often occurring. So what I do is I look at the frequency column, the number of days, which happens the most, and the biggest amount of frequency is 4 days. So number 3 sales is the mode, the most often occurring number of sales. Okay, so I just write a 3 in there. Okay, the median is a little bit harder. Okay, so there are basically 12 days. Okay, so if I wrote them all out in ascending order, the number of sales, the 12 amounts, then it would go something like 3, 3, 3, 3, because it happens 4 times, followed by 4, 4, 4, because that happens 3 times, 5, 5, 6, 7, 7. So if I was writing all those numbers in ascending order, that's what I would get. So there are 14 numbers. Okay, to find the median, I'm finding the middle value, and you can see that in the 14 days, the middle value would happen in here. Okay, so I write for the median, I write 4. Okay, the range is the biggest, take away the smallest, so that's quite simply 7 sales take away 3 sales, which also gives you a value of 4. So 3 marks available for that one there. Okay, last question is a bit harder, and there are 4 marks available for it. Okay, so after 3 weeks, the shop has a total of 90 sales of the camera. Work out the mean number of sales per day of the camera in the 3rd week. Okay, so how many sales did we have in the first 2 weeks? I go back to the table and I would just add probably another column. So number of sales in total, or number of cameras sold, is 3 times 4 there, which is 12. 4 times 3, which is 12. 5 times 2, which is 10. 6 times 1, which is 6. 7 times 2, which is 14. If I add all those up, I get 54. Okay, so 54 sales in the first 2 weeks. Okay, after 3 weeks, we're told there are 90 sales. So how many sales in the 3rd week then can we deduce? It would be 90, take away the 54 sales from the first 2 weeks, which gives you 36 sales in that 3rd week. So 36 sales in the last week. But what does the question say? Work out the mean number of sales per day of the camera in the 3rd week. Okay, so 6 days of selling. Okay, what's the mean? That's the common use of the word average. What is the mean number of sales per day? We only sell 6 days, so we divide by 6. Okay, so therefore mean per day equals 36 divided by 6, which is 6. Okay, 6 sales per day. It's a tricky question. 4 marks available for that. So where would I give you the 4 marks? I give you 1 mark if I can see calculation of 54 sales in the first week, in the first 2 weeks. A mark for working how many sales in the third week. Third mark for calculating the mean per day, and then the fourth for the correct answer from that calculation. So that should be straightforward. So 11 is a 5-mark question, so it's going to involve a bit more work. Diagrams a sketch, gives you the coordinate of point A, 10, 4, and B, 4, negative 6. Let me just write those in. So that's 10 and 4, sorry, comma there. And this one here is 4, negative 6. Okay, so we've got 2 coordinates. We've got to find the midpoint between these 2 points here. So we don't know exactly where that is. That's supposed to be a straight line. Forgive me, guys. So what I would do is I'd find, we've got to find the distance from the midpoint of this line, so somewhere around here, back to the point of origin here. Okay, so what I need to do is find a coordinate for this unknown midpoint here. And the way I do that is I look at the x part of both coordinates, the 10 and the 4. Okay, and to get the midpoint, you add them together and divide them by 2. So our midpoint is going to be 10 plus 4, which is 14, divided by 2, which is 7. So the midpoint is going to be 7, and then we do the same with the y part of the coordinates. Y part of the coordinates, we do 4 plus negative 6, and we half that to give us the y part of our new midpoint. Okay, so 4 plus a negative 6 is negative 2. Half of negative 2 gives me negative 1. Okay, so we know that our midpoint is going to be 7 along and minus 1 down. So roughly somewhere like that, say. Okay, with that coordinate. Right, so what I've got to do is I've got to find the distance from there back to the point of origin. So what I should know is, let's have a look. I'm going to have a right-angled triangle. It's not the best right-angled triangle in the world, so let me just zoom out a little bit more. Okay. I know that the distance of my midpoint, this bit here, okay, is 7 on the x-axis and minus 1 on the y-axis. So that distance there is 1. Okay, so using that information, the distance is the hypotenuse on that right angle triangle. So it's quite simply, let's call the distance d. The distance squared is 7 squared plus 1 squared. Okay, so the distance is the square root of 50. Okay, so that's the answer. But the only problem is it wants it as in the format of k root 2. So we're going to simplify the surd to get the final marks. We're going to simplify the surd roots 50. To simplify a surd, you find the biggest square number factor of 50, okay, which is 25, okay, and therefore I could simplify that. Root 25, positive root is 5, root 2, and that would give my answer in the format that it was asking for, okay, where k is an integer. Okay, so there are, like I said, 5 marks available. Give you 1 mark if you worked out the x part of the coordinate of the midpoint by adding together the x parts and dividing by 2. You get a mark for the y part of the coordinate by adding the 2 y parts and dividing by 2. You'll get a mark for expressing your problem using Pythagoras. You'll get a mark for giving you the distance as root 50, and your final mark for then simplifying that to give you 5 root 2. So 5 marks available in total. Tricky question. Okay, for a similar triangle question, it's going to involve a scale factor. It basically means that this triangle here is an enlargement of this one. It's being multiplied by something to each length's been multiplied by something to give the new length. So first thing you've got to do is you've got to work out the scale factor. Okay, so the scale factor is equal to what equivalent lengths have we got? We've got the 12 on this one, which relates to the 9 on that length. So to work out what 9's been multiplied to get to 12, you do 12 divided by 9, okay, which is 4/3. Okay, so our scale factor is 4/3. So to get QR, okay, the equivalent side is that MN, which is 6. It's basically 6 times the 4/3. Okay, and that will give you 8 centimeters. Okay. PQ. Where's PQ? Okay, so we're going to do the same again. Scale factor hasn't changed, but the equivalent length is the 8.11. So 8.1 times 4/3 would give you, well, you can treat it like fractions. 8.1 times 4, which gives you 32.4, and 1 times 3, which is over 3. So if you do that sum, you'll get your answer, which is 10.8 centimeters. Okay. 2 marks available for that latter part. The first mark for carrying out the sum 8.1 times 4/3, and the second mark for the answer, and the same with the one previous for those 2 marks. Okay, this question is straightforward. We've got to just tick 2 boxes for question 13 where the expressions could represent areas. Okay, so a length, the area of a rectangle we give centimetres squared, triangle centimetres squared. So it's a dimension times another dimension. Okay, so basically it could be that one, and if I expanded that one, that would be a dimension times another dimension as well. Okay, so hopefully that's fairly straightforward. 2 marks available. Question 14 is the difference of 2 squares. Basically that means that this could be rewritten as 3 squared take away x squared, which simply, factorising is the reverse of expanding brackets, which basically gives me 3 at the start of each of them, a plus x and a minus x. Okay, the difference of 2 squares, if you want to revise that. Okay, as soon as you recognise it's 1 square take away another square, then it's quite easy to factorise. This last question is a bit trickier. It's a complicated solving equations question, and the way I teach it is I get rid of a denominator at a time. So if I times everything by 4, that will get rid of the divide by 4 on the first term, but I've got a times 4 on the next one, so 4, 3y minus 1, still all over 2, got to get rid of that in a minute, equals 3. Okay, I can actually simplify that second term already because I've got a 4 and a 2, so let's just do that. Y, oh, hang on, made a mistake. I've got times everything by 4, guys. Okay, so I've got times everything by 4, so that 3 there should actually be 3 times 4 as well, which is 12. Okay, so let's just make that 12. Okay, so let's rewrite that. Y plus 2 lots of 3y minus 1 equals 12. Expand that bracket. Y plus 6y minus 2 equals 12. Okay, so let's just show you what I've done so far. I got rid of the divide by 4 by timesing everything by 4. So that gives me y plus 4 lots of 3y minus 1 all over 2 still equals 3 times 4, which is 12. That's where I made a quick mistake then. Can simplify the 4 and the 2. 4 and 2 cancel down to just a 2. And I've expanded that bracket to give me that. So y plus 6y minus 2 equals 12. Okay, let's just rearrange that. Simplify that. Y plus 6y is 7y equals 14. Y equals 14 divided by 7, which is 2. Okay, so I'm going to write a 2 in there. Okay, so 4 marks available. What are the 4 marks for? Well, 1, 2, 3, and 4, including the answer. Now there are numerous ways of doing it, as long as you are eliminating things and showing every step of your working. You get the right answer, you should still get all the marks available, despite what the marking scheme says. So always communicate every step of your working, and what you notice is my equal signs are pretty much lined up, so I'm communicating all my working vertically down the page. Okay, that should be straightforward. Okay, so this is straight line graph stuff. Find the equation of the straight line drawn on the grid. Every straight line can be expressed as y equals something times x plus something. Y equals mx plus c. Something you'll get familiar with before your GCSE. Okay, the m is the gradient, that tells you how steep it is, and the c is the y-intercept. That tells me where does my straight line cross the y-axis. So that's the first thing I normally write in. So y equals something x plus c. What's the plus c? Well, it crosses the y-axis at minus 2. Okay, so I'm just going to put the x in. What's the m? What's the thing that goes in front of x? That tells me how steep it is. Okay, what I do is I look at where it crosses the y-axis there, and I go, for every 3 it goes to the right, it goes 1 up. Okay, so basically for every 1 it goes to the right, it goes about a third up. Okay, so steepness is, we express it as a fraction, as a third. Okay, so for every 3 it goes to the right, it goes 1 up. Okay, ratio of 1 to 3. So we say 1/3 x minus 2. Okay, you get 1 mark for m, the gradient, you get 1 mark for the y-intercept, you express it as y equals mx plus c, it gives you, guys, your third mark. Okay, so third mark, y equals 1/3 x minus 2. People get really hung up on solving inequalities. Just treat them the same as equations. Is the best way of doing it. So I want to get x on its own. Use the balancing method to get x on its own. To get rid of the plus 5, you're going to minus 5 from both sides. So 2x is greater than, what's 12? Take away 5? 7. Okay. What's the last thing I've got to get rid of? So that x on its own. The 2. What's the 2 doing? It's timesing 2. So to get rid of a times 2, you divide by 2. So x is greater than, what's 7 divided by 2? 3.5. It's really straightforward. 1 mark for each step of that working. If you don't show your workings, you don't get the marks. Okay. So yeah, just get x on its own. Got rid of the plus 5 by minusing 5. so hence the 7 on the other side. Get rid of the times 2 by dividing by 2, hence the 3.5. Right. Solving simultaneous equations almost always comes up in the GCSE. So how would I go about doing this? The elimination method is the straightforward method. That means we're going to get rid of either the A's or the B's in order to solve the equations. So what I could do is I could times the second equation by 3, every term by 3, and that would give me 3a minus 6b equals 63. Lost my equal sign there, equals 63. I could have just as well times the second one by 2 to get minus 4b on that side. So we want to get the numbers in front of one of the letters the same, and that would do that. So I've got equation 1, I've got a new equation 2. They've both got 3 A's. The signs in front of the number 3's are both the same, they're both positive, so I can subtract one from the other. I normally subtract the smaller one from the bigger one. So I'm going to do 2 take away the second equation, take away the first equation. So 3a take away 3a eliminates my A's. Here we go. Minus 6b minus positive 4b would give me minus 10b equals 63 take away 3, which is 60. So to get b on its own, I get rid of a times minus 10. To get rid of a times minus 10, you divide by minus 10, which is minus 6, negative 6. Okay, so I can write that in my answer straight away. Okay, just at this point, I'll just tell you there are 3 marks available. I've got 1 mark for rearranging or changing one of my equations. So the coefficient, that's the number in front of the letter, is the same as the number in front of the same letter in the other equation. So they've both got 3 A's. That's 1 mark. Second mark is for eliminating and finding the value of b. And then the third mark in this case is going to be then substituting that back into one of the equations. So I'm going to put it into the original second equation. So in 2, and that gives me a minus 2 lots of negative 6. So a minus 2b equals 21. So let me just rewrite that. A minus 2 times minus 6 is plus 12 equals 21. So a equals 21, take away 12, which is 9. Okay, so I'll just write that in there. Okay, and that's my third mark there. Hopefully that makes sense. Question 17 combines basic percentage knowledge and standard form. Standard form is where we have a number times 10 to the power of something. And we can see that part B is going to be multiplying 2 numbers in standard form. Okay, so let's look at this one here. 5% of whatever that number is in standard form. What I do is I would always work out what 10% is by dividing by 10. So 10% is 0.82 times 10 to the 12. All I did was divide that by 10 to get that. Okay, so if that's 10%, 5% is half of it, which is 0.41 times 10 to the 12. But that's not in standard form, because in standard form, it looks like standard form, but the number has to be a number between 1 and 10. So I'm just going to bring that decimal point 1 to the right there. Okay, and that would give me 4.1 times 10 to the power of 11. Okay, This one here, the second one, deal with the numbers multiplied together first. 4.2 times 3, which is 12.6. And then index laws, 10 to the power 21 times 10 to the negative 8. You add the powers. So 21 plus a negative 8 will give you 13, 10 to the power 13. But again, that first number is not in standard form. Okay, so it's actually going to be 1.26 times 10 to the power of, well, if I've had to times that by 10 to the minus 1, or sorry, this one by 10 to the 1, then it's going to give me that there. Okay, so what I could do is just make that a little bit more straightforward by rewriting that first layer of working as 1.26 times 10 to the 1 times 10 to the 13. Okay, which then gets rewritten as 1.26 times 10 to the 14 by adding the powers of the powers the powers of 10. Okay, hopefully that makes sense. Okay, so we've got a vector question here. ABCD is a parallelogram. O is the point such that O to A is 3p. I'm just going to do that 3p. OB is, in fact, let me just make that a bit bigger. OB is 2p plus q, going in that direction, OB. And OC is 4p plus 3q. Okay, so vectors, probably one of the last topics that many groups, many sets learn before their GCSE. But there's some easy marks to get once we get our head around the basics. Find in terms of P and Q the vectors BA. Okay, so B to A. I've got to find a route from B to A using pathways that I know. So how do I get from B to A using pathways I know? Well, I would go this way. Okay, but I'm going to go against the flow of the arrows. So I would go minus 2p minus q. Okay, I'm going against the flow plus the 3p, which could be simplified to p minus q. Okay, it's pretty straightforward that for a couple of marks there. Okay, 1 mark as expressing it like that, and the second mark for simplifying it. So OD, bit harder. O to D. How do I get from O to D? I would go OC, and then I actually know CD because it's a parallelogram, so it's going to be the same vector as BA, which I've just worked out. So I can write that actually in. That there is P minus Q going in that direction. So the answer is 4p plus 3q plus p minus q, which could be simplified to 4p plus a p, 5p plus 2q. Okay, so 2 marks available for that one, 1 for the expression, and then 1 for simplifying. Okay, this question 19 is all about upper and lower bounds. Okay, we're told a tin of spaghetti weighs 250 grams, correct to the nearest gram. So tin of spaghetti is 250 grams to the nearest gram. So I would say the upper for that and the lower for that is, well, upper, what's the biggest it could be and still be rounded to 250 grams to the nearest gram, would be 250.499999999, etc. So I'm actually allowed to write 250.5. That's supposed to be one decimal point there. Okay, and the lower, smallest it could be and still be rounded to 250 grams is 249.5 grams on both of those. Okay, so that's the tin. Cardboard tray weighs 120 grams, correct to the nearest 10 grams. Okay, so tray, terrible brackets there. Upper and lower bounds for the tray. What's the biggest it could be and still be rounded to 120 to the nearest 10 grams? Well, that would be 124.99999, etc. grams, which I'm allowed to say is 125 grams, and the smallest it could be and still be rounded to 120 grams is 115 grams. Okay, so we're told a full tray carries 12 tins of spaghetti. 2 full trays are weighed. Find the maximum difference between the weights of the 2 trays. Okay, so the maximum difference between 1 tin of spaghetti, okay, is 1 gram. Is that right? Yep, 1 gram. So 12 tins is going to be 12 grams. And for a tray, the biggest difference is 10 grams, and there are 2 trays. Okay, so that's 20 grams. If I add those together, 20 plus the 12 grams, I get 32 grams. Okay, which is the biggest difference. Okay. Next question involves fractional and negative fractional indices. Okay, so we've got 16 to the power of a half. We know that's just another way of writing square root of 16. Okay, so quite simply 4 would get you 1 mark for that. The next one is to the power of negative a quarter. Okay, the way I teach it is get rid of the negative first, which creates a reciprocal, but I've still got the power of a quarter that I need to deal with. Okay, so we get rid of the negative by creating a reciprocal. Then we've got to get rid of the fractional indice. Well, denominator 4 means we go to the 4th root. So what times itself times itself times itself gives 1? 1. What times itself times itself times itself gives 16? 2. Okay, so the answer for that one is a half. And you would get 1 mark for creating a reciprocal and 1 mark for applying the fractional indice to get your answer. Okay, B is a little bit harder. Okay, what we're going to do is we're going to expand some brackets. Okay, and the way that I teach that is using FOIL. It's just the order that we expand. First, 2 times 4 is 8. So that's the first. Then the O for outsides, which is the 2 times negative root 3, which is minus 2 root 3. Then I've got the insides, root 3 times 4, which is plus 4 root 3. And then the last thing, which is root 3 times negative root 3, which is minus 3. Okay, so simplifying, 8 minus 3 is 5, minus 2 root 3 plus 4 root 3 gives me 2 root 3. Okay, so we can see that from the question, P is 5, and Q is 2. There are how many marks available for that last question? Just 2 marks, 1 for expanding, 1 for your final answer. Okay, so for this question here, we've got to find which equation goes with which graph. Okay, so this one here, y equals x cubed minus 2. Okay, so I know that it could be either this one or this one from my knowledge of what a cubic graph looks like. But which one crosses the y-axis at -2? And that looks like that one there. So I'm going to write E in there. Okay, this one here is an exponential one, so my knowledge of those is it looks like this, and this is the only one that I've got there, so I'm going to put A in there. And then the last one, x squared plus y squared equals 4. I often see that in simultaneous equations which require substitution, something like that. That's actually the equation of a circle. Okay, the only circle is that one up there, right, which is B. 1 mark for each. Okay, so data questions, cumulative frequency, box plot, histograms, and estimating the mean. This is a histogram question. They all tend to start the same with group data table, just up here. What I always look to do is look to add a column, and if it's a histogram, which it is, you can see that it's going to ask me to draw a histogram, then this column is going to be frequency density. If it was cumulative frequency, I have a cumulative frequency column. So frequency density. Frequency density is frequency divided by the class width. Okay, so what do I mean by class width? 0 to 1000 means the class width for this row is 1000. So frequency is 3. 3 times 1000. Let me just make that a bit bigger. 3 times 1000 is going to give me 3 divided by 1000, which is 0.003. The next one then, 6 divided by what's class width for this one? 1000 to 1200 is 200, so 6 divided by 200 will give me 0.03. The next one, 5 divided by 200 will give me 0.025. The next one, 4 divided by 400, 0.02. And the last row, 4 divided by 400, give me 0.01. Okay, so if I'm able to add that column, that's probably got me 1 mark in the question. Okay, it then does get a little bit harder because I've got to use that knowledge to then draw my histogram. And I'm really sorry, I haven't worked out how to use the ruler properly on this, so it's going to be a bit messy. First things first, find a decent scale. So we're going to find a decent scale. What did I go for? You guys are going to use a ruler, so it'll be much neater on yours. I went 0.01, 0.02, and 0.03. You probably come up with a better scale, but my first row is 0 to 1000, so it's going to be there, and it goes to 0.003, which is going to be there. Okay. The next one is 1000 to 1200, so it's going to be that kind of width, and it goes all the way up to there. Okay. Ruler formulas would make this much better. Okay, so that's given me the first two. I've got 0.03, 1000 to 1200, 0.03, 1200 to 1400, 0.025. Okay, 0.025. Where's that going to go? So it's that wide, 0.025. It's going to be approximately there. Okay, what's the next one? 1200, 0.025, good. 1400 to 1600, 0.02. 0.02, so that's that. And then the last one is 1600 to 2000, 0.01. Okay, so talking that wide to there. Okay, let's just come out. That's our histogram, our finished histogram. Okay, that represents all that information. Probably just label that FD for frequency density. 3 marks available, 1 for that right hand column to my table, and then the 2 marks for a correctly constructed histogram. Okay, this question involves the curved surface area of the cone, and if we looked in the front of the paper, that gives us that as pi RL, with L being that length there, which I'm not given. So I'm given R, the radius is 4, I'm given the height is 3, but I'm not given that sloping side L. So I'm going to use Pythagoras to find that. Okay, Pythagoras, which tells me that L squared equals 4 squared plus 3 squared. So L is root 4 squared is 16 plus 3 squared, which is 9, which is root 25. So L is 5. Okay, L is 5. That's going to get me 1 mark just for L equals 5. Plug that in. Therefore, love my triangular dots, which means therefore the curved area is pi RL, which is pi times 4 times 5, which is just 20 pi centimeters squared. Yeah, it's giving me the units in there. Well, always be careful. Make sure they include the units in the answer, or do it yourself. So it's probably a good habit just to write it yourself anyway for those 3 marks. So 1 mark for working out L, 1 mark for plugging it into the formula, substituting in, and 1 mark for giving the correct answer. Good. Okay, so this one's a probability question. Probability that it will rain on Monday is X when X is less than 0.5. Probability that it will rain on Tuesday is 2X. Given that the probability that it rains on exactly one of these 2 days is 0.5, find the value of X. So probability that it rains on a Monday is X, and so times not raining on a Tuesday is 1 minus the 2X. Okay, or it could be not raining on the Monday. So if it's raining is an X, so that would be 1 minus X for not raining on the Monday, and so times raining on the Tuesday, which is times 2X. So if I simplify that, so let's just put that in brackets. x minus 2x squared plus 2x minus 2x squared, which is 3x minus 4x squared. And we're told that the probability is 0.5 that it will rain on exactly one of those days. So what I'm going to do is I'm going to make it equal to 0. So I don't like the minus 4x, so I'm going to take everything to the right. So 0 is 4x squared minus 3x plus 0.5. So equals, if I multiply everything by 2, it gets rid of the half. 8x squared minus 6x plus 1. Because I can then factorise. I can factorise that second side. So that would give me 2 sets of brackets. And 4x minus 1 and 2x minus 1 all equals 0. So that's 8x squared minus 6x plus 1 factorised. So to get my values, each of those sides equal to 0. So 4x minus 1 equals 0. Well, that becomes 4x equals 1. X equals a quarter. Or the other bracket, 2x minus 1 equals 0, 2x equals 1, x equals a half. So I'm told in the question, what are we told in the question? X is less than a half. Okay, I don't know whether you saw that, sorry, let me just go back. X is less than a half. So just going back to our answers there. Can only be the value of x, which is less than a half. Well, that is a half, so that means that's our answer. Okay, so a bit complicated to get your 5 marks, but let me try and help you with that a little bit. Okay, so you would get 1 mark if you were able to demonstrate your understanding of this bit. 1 mark, 1 mark for that as well. You get your 2nd mark for getting to the point where you've expanded the brackets and collected the like terms. So if you've got that, or the one where I've doubled every term below it, that gives you your 3rd mark. You get your 4th mark for factorising, and then you get your 5th mark for solving the equation. Okay, so this is a circle theorem question. Okay, what I've got to do is I've got to prove that this angle here is the same as this angle here. So let's just call that x there. I know that if I drew a straight line down, that straight line OC is at right angles to DC, which means that this little angle here is 90, take away whatever the x is. Okay, if I connected a line up there, I know that that's a right angle, come on, that's an isosceles triangle, okay, because O to A is the radius of the circle and O to C is also the radius, which means that there is also 90 take away x. 90 take away x. Okay, so if they're both 90 take away x, let me see if I can make it a bit clearer. Angles in a triangle add up to 180, so that means AOC is going to be 180 take away the two 90s minus 2x, which is 2x. Angles at the circumference are half the angles at the centre, which means that is x there. Okay, so that's my proof. Is probably a bit more complicated than it sounds more complicated than I meant to explain it, but let me just go through it again. So what you've got is you've got a tangent there which is at right angles to the centre of the circle. So I know that this angle here is 90 take away whatever that is, so let's call it 90 take away x. This is also 90 take away x because it's an isosceles triangle. Okay, if I add those up, I get 180 minus 2x. So 180 minus 2x, so that means that must be 2x if they all add up to 180. So if that's 2x, that's going to be half of it, because it's one of the circle theorems that the angle at the centre is double the angle at the circumference, or the other way around, circumference is half of the angle at the centre. Okay, so I must make sure that I get all 3 marks. So where do I get my 3 marks? You'll get one of them for basically saying that OCA is 90 take away x. Okay, you'll get 1 mark for showing that AOC is 2x, and the reason why, and the final mark for saying that ABC is AOC divided by 2, okay, which is x. Okay, hopefully picture paints 1,000 words, and if you got all that information you should get all your marks.